Good day. Today's topic covers grade 8, 9, 10, 11 and 12. In the later grades with more detail, but in grade 8 and grade 9 merely to calculate the equation of a line segment using analytical geometry. In our previous topic, we handled how to calculate the gradient of a line segment, and we said that the gradient is the change in y over the change in x. In this instance, we will learn today the equation of a line. Gradient is associated strongly with the equation of the line. Without this, I cannot calculate the equation of this line. First things first, you will see this is a straight line. It tells me that the relationship of y and x is linear. It's the same as in the number patterns that we did, the linear number patterns. So we say that if there is a certain growth and that growth continues the same, we say there is a linear growth. Let's get straight into it. The equation of a line, y is equal to mx plus c. There are other different representations of this, but for the purpose of grade 8 and grade 9, I will focus on y is equal to mx plus c. First, we have to find the gradient, and this we've learned in the previous chapter, that the gradient is equal to the change in y over the change in x. So we find any coordinates on this line segment. In this instance, there is no actual coordinates that I can read off the graph, but I know that this one is 0 and 4. So my distance from that point to this point is equal to a -4 change. My distance from this point to that point is a -5 change. So if I move from that point to this point, I will need to move 4 units down and 5 units across to my left hand side, which means my change in y is a -4 because I'm moving in a negative direction on the y-axis, and my change in x is a -5 distance because I'm moving in a negative direction on the x-axis. So my gradient is 4 over 5. Now I substitute this gradient into the equation of a line, which is y is equal to mx plus c. Once I've done this, I will see that I've got 3 different variables here, y, x and c. Now if I take any of the 2 coordinates that I've used, which is -5 and 0, that one that the line passes through, or I can use 0 and 4. Now I'm going to substitute the -5 in the place of x and the 0 in the place of y. Then I only need to calculate c. So what happens now? 0 is equal to 4 over 5 multiplied by -5 plus c. 5 will cancel out 5. 4 times -1 is -4. I need to isolate c. So I add 4 on the right hand side. I must add 4 on the left hand side. So my answer for c is equal to 4. If I now substitute the c value into my equation, I will find that y is equal to 4 over 5 times x plus 4. If I had decided to use 0 and 4, which was also available, which means my x value is 0, and I substituted in this equation here 0, and the 4 is my y value. If I substitute the 2 in those places, 0 multiply with 5 over 4, 0 multiply with anything is 0. So I will find also that c is equal to 4. So it does not matter which coordinate I use as long as the line passes through that coordinate. I can use it into my equation to solve C. And generally, I will choose the one that will be easiest for me. You will now also notice that the C value is my y-intercept. It means where the graph or the line or the function cuts the y-axis. You will notice that the axis has an arrow point showing that it will continue going in that direction. It will continue to increase beyond this point. It will continue to increase beyond that point, and it will continue to increase beyond this point. Let us now look at another example. Here is my line segment. It passes through 2 and it passes through 5. First thing that I know, I need to find the gradient. The gradient is the change in y over the change in x. So if I move from this point to this point, I will move 5 units down. And I will move 2 units across. So 5 in a negative direction for y, my change in y, over my change in x, which is 2 units in a positive direction. So my gradient is negative 5 over 2. I substitute this in my equation y is equal to mx plus c in the place of m. Now I still need my c value. If I have the line given, I can see my c value is where it cuts the y-axis. My c value is 5. I can substitute it in there. If my c value was not given, if my line is not passing through a particular point that I can see on the graph paper, then what I will need to do is I will need to take any coordinate that is available on that line. So if I substitute 2 and 0, which means my x value is 2 and my y value is 0. So if I continue now, 2 will cancel out 2. Now we'll be left with negative 5. Then I add 5 on this side. I must add 5 on that side. So c is equal to 5. Alternatively, I could also substitute 0 and 5. My y value is positive 5 and my x value is 0. 0 multiplied with any number remains 0. So c is equal to 5. So the most important thing to take out of here is if I'm given a picture and I know where the graph cuts the y-axis, that coordinate will be my c value. That coordinate at that point will be my c value in my equation y is equal to mx plus c. Here is a few examples. Find the equation of the following line segments: AB, CD, EF, and GH. I tell you here also the hint. Find 2 coordinates on the line first. For example, on line segment CD, I've got 0 and negative 1. I've got 2 and 0. I also have 4 and 1. And I also have 6 and 2. So if I look at any of those coordinates, I can calculate the gradient between any 2 points, especially if I'm not going to be given a picture. I need to calculate it algebraically. If I'm given the y-intercept, where the line cuts the graph, I know what the equation of this line will be if I have the gradient, and I use these values as my C values. Good luck. I trust you will find it easy to calculate the equations of the following lines.